हेलो गाइस, अगर आप चैनल पर नए हैं तो इसको प्लीज़ सब्सक्राइब कीजिए। अगर आपको वीडियोज अच्छी लग रही हैं तो इनको शेयर कीजिए ताकि दूसरे लोग भी अच्छे से इसका फ़ायदा उठा सकें। ठीक है, आज हम ऑर्डिनरी डिफरेंशियल इक्वेशंस का पार्ट सेकंड करेंगे। केस फर्स्ट हम कर चुके थे, केस सेकंड करेंगे। If mxy equal to f of xy into y and nxy equal to g of xy into x for some functions f and z, then 1 by mx minus ny is an integrating factor providing mx minus ny is not equal to 0. In previous case, we say if there is mgx we have expression mgx plus mgy equal to 0, where m is of the form fx into y and multiple of y, and n is a function of xy which is of the form g of xy into x, where f and g are some function. If there is condition that mx minus ny is not equal to 0, then we have integrating factor 1 by mx minus ny. Similar as case first, in case first we have studied if mdx plus ndy equal to 0 and this is homogeneous. I am recalling to you the previous case that this is homogeneous and mx plus ny is not equal to 0, then 1 by mx plus ny is an integrating factor. And second case is if mx plus ny equal to 0, then here 1 by x square, either 1 by xy, either 1 by y square can be integrating factor. mxy equal to f of xy into y. In this case, if function is function of xy into y and nxy equal to function of xy into x, multiple of x, and in this multiple of y, then if mx minus ny is not equal to 0, remember this one, if mx minus ny is not equal to 0, then 1 by mx minus ny is an integrating factor. And if mx minus ny is equal to 0, then equation already would be exact equation. Okay, based on this case, similar to previous case, we solve a question. See the question. Solve x square into y cube plus xy square plus y into dx plus x cube y square minus x square y plus x into dy equal to 0. First of all, we see is it homogeneous? No. 2 plus 3 5, 1 plus 2 3, and this 1. 3 to 5, 2 plus 1 3, this is 1. So there is different degree, so this case is not valid. First case is not valid. We see second case is valid or not. In which second case, what is m was f of x into y, function is x into y into y into y. See, we can take common y, and after that we get x square y square plus xy plus 1, and in this we can take x as common factor, x square, remaining is x square y square minus x into y plus 1. This is n and this is m. And from previous case we see that z of xy into this is function of x. So we can apply our integrating factor formula, that if mx minus ny is not equal to 0, then 1 by mx minus ny is an integrating factor. And if mx minus ny is equal to 0, then equation would be exact. If you want to check it is exact or not, then what the condition for check differential equation is exact or not is del f del m by del y equal to del n by del x. If partial derivative of m with respect to y is equal to partial derivative of n with respect to x is equal, then equation can say it is exact differential equation. Now we check mx minus ny is equal to 0 or not. Now x square y cube minus xy square plus y into x minus n x cube y square minus x square y plus x into y. So what we get? X cube y cube minus x square y square plus xy minus x cube y cube plus x square y square minus xy. So plus xy minus xy cancel, x square y square cancel, x cube y cube cancel. So what we get? If mx minus ny is equal to 0, this is 0, so this is exact differential equation. This is already exact. When you see the condition, this is satisfying. Okay. If this is not exact, then next process we will start 1 by mx minus ny is an integrating factor. I think got my point. If you get any problem, then ask me on comments. Next, case third. What is the case third? If the equation mx plus ny is equal to 0 is such that this is misprint. 1 minute. If mx plus ny equal to 0 is such that del m by, note it, del m by del y minus del n by del x divided by n is a function of fx. Then we said that exponential raised to power integration of fx dx is an integrating factor. At the similar point, mgx plus mgy equal to 0 is such that del n by del x minus del m by del y divided by m is a function of y only. Then we say that exponential to the power of integrating f of y dy is an integrating factor. Both results are similar. How can we learn both? Check it. If mgx plus mgy equal to 0, then partial derivative of m with respect to y minus partial derivative of n with respect to x. When we subtract del n by del x, then divide by n, and n what we define partial derivative of x na, then it would be partial derivative of x. We subtract derivative of n with respect to x, we get function of x, and after dividing this we get n. And similar case, if we take del m by del y means partial derivative of m with respect to y, then see function of y only, we get the function of y only and dividing by m. So you can this is not a trick, but you can remembering like that key, how can we minus. If we do first case, then we have the case that it is a function of fx, because we want to find out na integrating factor na, e raised to power fx into fx. If you misplace this is a function of fy and then e raised to power function of fy is an integrating factor, that would be wrong now. That's why I am saying that if you subtracting partial derivative of n with respect to x, then dividing by n, and we get the partial derivative जिसके रिस्पेक्ट में हम डेरिवेटिव कर रहे हैं वही वाला फंक्शन आपके पास दोबारा से आ जाएगा। ऐसे ही हमारा फंक्शन ऑफ y में भी होगा कि पार्शियल डेरिवेटिव ऑफ m विद रिस्पेक्ट टू y जब हम कर रहे हैं तो फंक्शन ऑफ y ही हमें मिलेगा। जो सब्ट्रैक्ट लास्ट टर्म में जो सब्ट्रैक्ट कर रहे हैं ना, सिमिलर हमें फंक्शन ऑफ दैट वेरिएबल ही मिलेगा। After that we get a integrating factor exponential to the power of fx dx and exponential power of fy dy is an integrating factor. Next case, fifth case is more important, but before that we continue example based on these two cases. Now first case, y plus 1 by 3 y cube plus 1 by 2 x square into dx plus 1 by 4 into 1 plus y square into x dy equal to 0. So what cases are valid here? What cases are valid here? So see, if this is homogeneous, first case is homogeneous, second case is function of xy into y is m and n is g, function of xy is into x, and third one is that mx plus ny, that was the free, and directly we would like to minus, we would do like to solve that if mx minus ny divide by n, then if function of fy, then integrating factor is e raised to power fy dy, and if curl n by curl y minus I get something wrong, sorry, is this is 1 minute, yes, I sorry for this. Partial derivative of m with respect to y and minus partial derivative of n with respect to x is equal to function of x and e raised to power function of x into derivative of with respect to x. And when we do 1 minute, then if curl n by curl del n by del x minus del m by del y divide by, what we get, by m equal to function of y and integrating factor is e raised to power function of y into dy. सिंपल। अब हमारा काम क्या है कि हम ये देखेंगे कि कौन सा केस इसके ऊपर अप्लाई हो रहा है। Is it homogeneous? No. Then first case is cancelled. Is it function of xy into y? Can we take common from this equation? Can we take common from this equation? No. Yes, because here is x, multiple of x, but here is, can we common y? No. So second case is also skipped. We see case number 3rd and case number 4. 3rd and 4th. In 3rd, what is m? This is m. What is n? This is n. Partial derivative of m with respect to y. First of all, we want to find out partial derivative of m with respect to y. What we get? 1 plus 3y square divided by 3 plus 0, and partial derivative of n with respect to x is 1 by 4 into 1 plus y square. X into derivative of x is equal to 1. So del m by del y is not equal to del n by del x. First of all, we can say that this is not an exact differential equation. So we want to find out its integrating factor. How can we find out? Yes. Check the case third. Del m by del y minus, put the value in case third, del m by del y and del n by del x. What we get? Write it here. 1 plus, cancelling 3 by 3, minus del n by del x, 1 by 4 into 1 plus y square divided by n. What is n? N is 1 by 4, 1 plus y square into x. Subtracting this, what we get? This is 4 into, by taking LCM, 4 into 1 plus y square minus 1 plus y square divided by 1 plus y square, and taking 4 to 4 upper side and x. Here what we get? 4 into 1 plus y square minus 1 plus y square is getting to 3 into 1 plus y square and multiply by 4 divided by 1 plus y square into x, and cancelling 1 plus y square to 1 plus y square, we get 12 by x. Is a function of x only? Is it case third? Is it okay? Or have we done something wrong, or either anything? Del m by del y minus del n by del x divided by n. Yeah. There is a when we take LCM, there is 4. So 4 cancelling out with 4, and we get 3 by x. Then what is integrating factor? Is the e raised to power 3 by x dx. And what we get answer? E raised to power 3 log of x. And what is this? X cube, by applying property of logarithm, and e is 1. So integrating factor is x cube. कर लोगे? फाइंड हो जाएगा. सिमिलर हम फोर्थ वाले पे कर सकते हैं, सिमिलर ही होगा सब. नेक्स्ट क्या होगा? एक्स वाई क्यूब प्लस वाई इंटू डी एक्स प्लस 2 इंटू एक्स स्क्वेयर प्लस वाई स्क्वेयर प्लस एक्स प्लस वाई 4 इंटू डी वाई इक्वल टू 0. This is based question on case 4 that would I recommend to you. You should solve this by pausing this, and after that if you didn't able to solve, then ask me in comment section. I will provide you solution. In fifth case, this is last remaining case to find out how to find integrating factor. If the equation dy by dx is equal to function of xy is of the form x raised to power a into y raised to power b into my plus my dx plus nx dy plus x raised to power r into y raised to power s into py dx plus qx into dy equal to 0. एक्चुअली दिखने में ये थोड़ा सा डिफिकल्ट लग रहा है, बट है नहीं इतना. एक दो बार पढ़ोगे, रिवीजन करोगे तो हो जाएगा, बट इट इज़ इम्पोर्टेंट. इसके ऊपर बेस्ड बहुत सारे क्वेश्चन आते हैं. डायरेक्ट क्वेश्चन पूछे जाते हैं, फाइंड आउट द इंटीग्रेटिंग फैक्टर ऑफ डिफरेंशियल इक्वेशन. That's why if dy by dx is equal to function of xy is the form of this, one, where a, b, m, n, r, s, p, q all are constant, then integrating factor is x raised to power h into y raised to power k, where h and k are chosen. Show that after multiplying the given differential equation by integrating factor, it becomes exact. Our main motive is to become a differential equation to be exact now. So here is what integrating factor is x raised to power h into y raised to power k, where h and k are chosen. Show that the differential equation should be exact. So this differential equation can be solved by our described method. And after recalling my second lecture of this sequence, that when we define an exact differential equation, then we find a solution of differential equation very easily by a method which is given above. You can see my previous lecture to see that how we find out a solution of exact differential equation. Why we do integrating factor and all of this I explained in my previous lecture. You should see my previous lecture. Now based on this case, we do a question which is question number 5. Solve x into 3y dx plus 2x into dy plus 8y 4 into y dx plus 3x into dy equal to 0. When we see that it is not of the form of previous, so use this as here x raised to power a, y raised to power b of the form of this, and m y dx plus n x dy, mgx plus ndy, and multiplying with y and ndy multiplying with x, and plus x raised to power r, y raised to power s into py dx, pdx plus qdy, and after pdx multiplying with y and q dy multiplying with x equal to 0. There is some similar concept है कि जो आप थोड़ा सा ट्रिकी करके इनको याद कर सकते हैं. जैसे here is x raised to power a, y raised to power b, x raised to power r and y raised to power s. There a, b, r and s are constants, and mgx plus ndy, pdx plus qdy, and mgx with mdx we multiply y, and ndy we multiply x, and pdx we multiply y, and plus qdy we multiply x. If you see there is an opposite relation between all of these. So here comparing with this, here x raised to power and y raised to power 0, x raised to power 1, y raised to power 0, 3y dx, it means 3 is m and y multiply and dx, plus 2 is n and nx dy, plus 8y is 4. Here is y raised to power 4, s is 4, r is 0, x raised to power 0, r is 0 into y dx. Here p is 1 and q is 3. So comparing with previous section, we do find out that this is the values. Now first of all, we would like to see is it exact or not. For exact, you should try the condition that del m by del y is equal to del n by del x. If this is equal, then equation is exact. If this is not equal, if del m by del y is not equal to del n by del x, then it is not exact. If not exact, then we find its integrating factor exact. So finding its integrating factor, I know this is not exact, so if you want to try it, you can do this. I am doing next process. How can we find its integrating factor? By taking previous case, integrating factor is x raised to power h into y raised to power k. If we get the integrating factor, what we do, multiplying the equation by integrating factor, and what we get, 3 x raised to power h plus 1 y raised to power k plus 1 plus 2 x square h plus 2 y k, 3x h plus 1 y k plus 1 h into dx 1 minute into dx into dy into dy plus 8 x raised to power h y raised to power k plus 5 into dx plus 8 3 are 24 x raised to power h plus 1 and y raised to power k plus 4 into dy. Now separating dx and dy, there is dx multiple of dx and dy together, we taken together 3x raised to power h plus 1 y raised to power k plus 1 plus 8 x raised to power h y raised to power k plus 5 into dx plus 2 into x raised to power h plus 2 y raised to power k plus 24 x raised to power h plus 1 y raised to power k plus 4 into dy equal to 0. This is m dx plus this is n. If after multiplying integrating factor we get the differential equation is exact, and exact is del m by del y equal to del n by del x. After multiplying this and we get this whole and dividing this, so derivative of m with respect to y and derivative of n with respect to x we find, and after that we do the process. We get a result 3k plus 1 into y in raised to power k x raised to power h plus 1 plus 8 into k plus 5 into y raised to power k plus 4 into x raised to power h equal to 2 times of h plus 2 into x raised to power h plus 1 into y raised to power k plus 24 into h plus 1 into x raised to power h y raised to power k plus 4. When we equating coefficient of same power, what we get? We get 3 into k plus 1 equal to 2 times of h plus 2. This is the same powers, y raised to power k and x raised to power h plus 1. So similar when we equating this and this one with this one. Second one is the 8 into k plus 5 equal 24 into h plus 1. By solving we get h and k values, and then what is the h and k? After solving this, h and k is 1 1. So what is the integrating factor? By substituting the value of h and k in the integrating factor, x into y is the integrating factor. Then if question is you find integrating factor, so our solution is finished. If he want to know what is the solution, and after multiplying this and this we get a solution. You can try if you want to do this one. Thank you. Thank you, dear. If you like my videos and if you want to give any suggestion, then you can do it in comment section. I would be appreciable to your comments, and please share, subscribe my channel. Thank you.